Okay, we're going to look at linear relationships, and most of this is going to be review, but I want to make sure that we are making the connections between how linear relationships are represented in tables and in graphs and in equations. Okay, because it's going to be really important now as we move to wrapping up proportionality as far as in all of these forms. Okay, so what I've done is I copied the part of the table for the pizzas in the exercise you just did with Royals and Howdy, and then in C where you had Howdies and it was for pickup and delivery. So those tables are already done, and we're going to talk about them. In the a relationship is linear if it goes up at a constant rate, and I'm sure you heard that last year plenty. Okay, so it goes up at a constant rate. That means that in the table, okay, every time I'm going up. I go up by 13. I go up by 13. I go up by 13. Or on the top, I go up by 12. I go up by 12. I go up by 12. Every time I add 1, I'm increasing the other value by the same amount. And you can see it also happens in here. On the other table, I'm going up by 13, I'm going up by 13, I'm going up by 13, and going up 13. And even on the top part where there's delivery, I am increasing by 13 each time. So in the table, I can see that both of these relationships are linear. Okay, what does it look like in the graph? Okay, so let's graph these, and I'm going to do the best I can in making this as neat as possible, but you just have to put up with me. For 0, 0, here it is, 0, 0. 1, 12, 2, 24, 3, 36, and 4, 52. And I'm going to say that that is a straight line. Okay, and I'm going to do Howdies. Now, Howdies is going to be a little bit more. Okay, Howdies also starts here, but it's 13, and it's 26, and it's 39, and it's 52. So it's a straight line. Okay, you know, you have to put up with my drawing, but it's a straight line because I'm going up every time. So both of those are linear, and you notice in the red it says that a graph looks like a straight line, and it does. It's a straight line. That's how the graph looks. And I want to do the other graph, so you notice here for pickup, and this is going to be a little different, so I want to make sure. So listen carefully. The pickup, I'm not adding anything. So notice I'm starting at 0, 0. I'm going 1 is 13. 2 is 26, maybe here. Of course, if I had graph paper, it'd be better. 3 is 39. And 4 is 52. Okay, and there's my straight line, similar to the one in the other one, in the first graph we did. Now, we're going to look at the pickup. Remember we talked about this when I went over it in the book, in the last video. I'm starting with 5 because before I figure out anything, I know that delivery is going to cost me $5 plus whatever my price of my pizzas are. So when I start this line, I'm starting here. So notice I'm not starting at 0, 0. I'm starting on the y-axis. And then 1 would be 18, and 2 would be 26, and 3 would be 39, and 4 would be 57. And this is going to basically be a line that is going to be, oh my gosh, that is terrible, Jeannie. Okay, Mrs. C, not a very straight line, but I'm telling you that this should be. This should be a straight line. And it's parallel because at each point, I'm exactly 5 more. But I want you to especially notice that on the y-axis, I did not start at 0, 0. I started at 0, 5. So now I want to move into what the equations would look like. Okay, so the equation for Royal is, and let's get blue, okay? The equation, I'm just going to do these in black. The equation for Royal, okay, is, and we did this in the last, I want to show, just want to do it again. The equation is going to be the cost of the pizzas is $12, right, times the number of pizzas. And the cost for Howdy's is, the cost of the pizza is $13 times the number of pizzas. So no matter how many pizzas I have, I can figure out how much it's going to cost me for each of those pizza places. Okay, the new piece now is what happens when I have delivery. What happens with this? Well, I'm going to have still 13 pizzas, right? I'm still going to, $13 per pizza. So I want to do an equation for Howdy's delivery. How do I know how much that's going to be? So Howdy's delivery would be, I still know they're $13. So here's what we got. $13 equals, the cost equals $13 times the number of pizzas. But I know that to that price, I'm adding $5. And that's what that equation would look like. So here we go. Let's look at this. Here is my constant, 12. And it's in the equation, and it's in the tables. It goes up by 12, and it's in the graph. It goes up by 12. That is the constant, okay? That is the constant increase. In Howdy's, the constant increase is 13, and that's what it looks like in the equation. But when we start adding something, okay, then I'm looking now at, I'm saying, I have this constant, but I have this piece that I'm adding. Okay, so I have a constant. So this is linear. That is linear, goes up by the same amount every time. This is linear, goes up at the same amount every time. This is also linear. It is linear because it has a constant that I'm multiplying times the n every single time. And it's important to note because in proportionally, we are going to start looking at the difference between a graph or a relationship that starts at 0, 0 and one that does not. But for today, for this video, this is all we're going to go over. Okay, so I just wanted to make sure this is all clear because we're going to build on this. So if you don't understand this, you need to ask me questions. Okay, good job.